Greetings for the day, everyone. I will be telling you about our work titled Reverse Dictionary Using an Improved CBoW Model. We are a group from Indian Institute of Technology, Gandhinagar, and we have done this work under the guidance of Dr. Mayank Singh. We all are familiar with normal dictionary and have used it sometime somewhere in our life. A dictionary helps us to find the meaning of a word. But there are times when we know the meaning of a word, but we are unable to recall the exact word. This is known as the tip of the tongue problem. Reverse dictionary helps to find the word given its definition. For example, if we input a phrase as the state of being happy, we will get happiness as the output using a reverse dictionary. Therefore, we believe to put forward a solution that would help people in situations where they are unable to express a word that represents an idea in their mind. Scholars, writer, new language learner, and many more people will be benefited from this. We have studied previous work in this field, so let's go through some of the previous work on reverse dictionary. Popular reverse dictionary models like OneLook are dependent on matching the user's input with the definitions accumulated in the model and then finding the appropriate word. In the paper proposed by Lee Zhang and others, they have used a multi-channel reverse dictionary model with multiple predictors for recognizing the target word attributes. Hill and his teammates built a reverse dictionary using deep learning. They use models such as bag of words and LSTM, recurrent neural networks. But they have trained their model exclusively on dictionary data for the purpose of reversing formal word definitions only. The paper titled Efficient Estimation of Word Representations in Vector Space by McColv and others use a simple log linear model which reduces training time. In our model, we use an improved CBoW model, which is a combination of recurrent neural network and traditional CBoW model. And this we call as recurrent CBoW model. Inspired from the paper of Q Wang, which is titled as Two Improved Continuous CBoW Models. In the case of recurrent neural network language models, the input layer consists of n-1 words before the target word as the context. Classical recurrent neural network language models can fully utilize the word order in this context, due to which its behavior is better in comparison to the traditional n-gram. But recurrent neural network language model is known to be complicated in general. Whereas in case of continuous bag of word model, the input layer consists of constant number of words before and after the target word, without any sense of word order among them. Due to this constraint that is applied in context, some important part of semantic information is lost. We have proposed a recurrent CBoW model which draws motivation from both of these classic models. This way, our model has benefits of both CBoW and RNN, while stripping away the complications associated with recurrent neural network. As we can see in the architecture, the model contains three layers: the input layer, hidden layer, and the output layer, which is similar to the vanilla CBoW model. The context information that is contained in the hidden layer vector is utilized in a cyclic manner by backpropagating the hidden layer information as input. This helps in providing better word order information about the context to the CBoW model. Initially, the W feedback is a zero vector, and during the training process, input goes ahead and W feedback keeps on updating. Hence, we obtain the word embedding in the hidden layer as shown in the formula. It is the sum of word embeddings in the vocabulary and word embeddings that we receive as feedback. Some of the challenges that we might encounter is that the input may not precisely match the language dictionary definitions. User may input definitions that have a combination of one or more languages. In that case, the output will contain anomalies. We intend to solve this problem by curating our own dataset consisting of several different forms of informal definitions and their respective target words. This aside, handling unknown or out of the vocabulary words will be a further issue. However, it is clear that without introducing any extra computational complexity, the recurrent CBoW model can therefore capture better contextual information than the traditional CBoW model. We would like to extend our solution further towards working with multiple language and dealing with code mix input. That's all from my side. Thank you.